So, all right, guys. So, in continuation of our class, which is multimeter master class. So now we are now getting into the one of the advanced level of multimeter usage topic, which is GR tracing universal method. So, as a student, I want you to take this topic very serious. So, go over and over it again after complete this topic. Okay. So, very important. This is one of the crucial aspects of multimeter usage. Okay. So now let's move into the class. Okay. So when we are talking about GR, okay, GR, the full meaning of GR um is grand reading. Grand reading. So that's the full meaning of GR. Okay, so the application is GR. So full meaning is grand reading. So when you are taking a grand reading, all right. So now, so when you are taking a grand reading, it means that you are measuring the resistance between a circuit line and the ground. You are measuring the resistance between a circuit line and ground. So in order to carry out the GR reading on multimeter, so you have to place the black probe on the line you want to test and the red probe on the ground. So that's the way of placing your probe if you want to get the actual result of GR reading. You remember in our code testing class, this is also called reverse reading. All right. So it is one of the fastest diagnostic testing trick before even powering the phone. Yes. So before you insert any power source like battery or charger to phone, so this is one of the fastest method of testing to fix out a fault. So now, why GR reading is very important. So GR reading help you to quickly detect short circuits, damage IC, and line condition, whether it's eddy or faulty. So we have two lines we are measuring on mobile PCB. Okay, so the power line, that's the power line, and the signal line. Also, we have the third one. So the third one is just general. That's the GND line. Okay. So in order to know whether the line is eddy or faulty, so that's what we use GR reading to test. Okay. All right. So when we are talking about GR reading, so we said that GR reading is measuring the resistance between a circuit line and the ground. Okay, so we are measuring the resistance between a circuit line and the ground. So what does that mean? So it means that you are measuring the current flowing to the ground. If you have high value, it means the line of circuit is eddy because there is high resist of current flowing to ground. But for low value means there is low resist of current flowing to ground. You understand that word? That's why GR reading is one of the best method of multimeter to fix out a fault. Okay, to check any line condition. All right. So now let's try to go overview on this word that when we have high value, we have the high resistance. When we have low value, we have low resistance. Let me try to put it in a very simple way for you to understand what does this GR reading mean. See, many technicians use this method to troubleshoot a fault, but they did not really know the deep of that GR reading, just that they just know it as a common way. So that's why this class is for you. So not only that you just using the method, but you will be able to understand. So understand is very matter in whatever we are doing. Okay, All right, so now, in order to make this clear to you, let me use some terms on mobile phone board. So we have Fibus, we have Fibats, we have VCOR. Okay, so Fibus, that's the voltage that is coming from our charging port. At least the maximum is 5 volts. Okay, Fibats, so the minimum is 3.7 volts. That's the voltage coming from your in the Fibat line, coming from your battery. All right, or your charging IC. So the VCOR, that's the voltage the CPU need. So the VCOR voltage is in between 0.6 volts to 1.2 volts. All right, so depend on the design of that mobile phone. So for the common one, let's use 0.8 volts. 0.8. All right, so this is the voltage. Okay, according to the Ohm's law, so the amount, if there is increase in voltage, there will be increase in current. So the amount of current is also the same as the amount of the voltage, that is the force that is pushing it. You understand? So they are the same. So the potential difference is what we call voltage. All right, so we are not into that now. So we are just trying to use that as a backup of our class, of this class. Okay, so now look at this voltage. You can't expect that this is the 5 volts, this is the 5 volts line. This is the 3.7 voltage line on a circuit, and this is the 0.8 volt, that's the VCOR voltage line on a circuit. You can't expect that the amount of current that will be flowing here is the same as 3.7 volts. It's not the same. Okay, you can't compare the 3.7 volts to 0.8, the amount of current that will be flowing here. This means that there will be a small current flowing inside this line. There will be much current flowing inside this line of 3.7 volts. There will be big amount of current flowing in this line of 5 volts. Do you understand? Okay. Now, let me say that whenever I want to take a GR reading, okay, if you have a I value, for example, now maybe for our Fibus, for example, for our Fibus line now, so if we take a GR reading and we have like 700, okay, that's the 700 diode value, and we take the GR reading of 3.7 volts, so we have like 500. There must be a difference in their diode value based on the voltage passing through them, which is also equal to the current flowing that line. Okay, so now when we measure the GR reading of this 0.8 volts, we have maybe 60 diode value. All right, so when we have the I value, so which one is the I value in this three? This one is the first one, second one, and this one is the last low value. So when we have a I value, that's it, we have I resist of current. Another word for resist is obstacle, obstruct, obstruction. So when there is obstacle, or there is I resist of permission. Okay, so you said that if there is I value, that is, there is I resist of current flowing to the ground. This means that in 5 volt line, For current to flow very much inside that line is because there is high resist of current flowing to the ground. That is the permission for current. See, there is no line that doesn't flow current to the ground because there must be a resist, little resist. So if there is too much rushing of current into the circuits, there will be a problem. So at least we have a little resist. Depending on the voltage, we determine the resistance. Okay. Now we are now measuring in this 5 volts. Now we have a high value. This means that the current that is leaking that is going to the ground is very small, very small, because there is high resist of current flowing to the ground. You understand? So this means that in that line, much current will flow. Okay. Now for 3.7 volts, also the current that is going there can just can increase little bit than 5 volts that is going to the ground, can just little bit increase, and much current is flowing to the circuits. Okay. All right. So now for 0.8 volts, it means that if there is a low value, we have a low value. It means that there is a low resist of current flowing to the ground. What does that mean? It means that the current that is going to the ground here is very large, and there is a low resist. That is, for example, now this is what we call resist. This is the erosion. This is the erosion. Now we put a block, a little block on this. Okay, when this erosion is very bigger. So when it reaches to this block, what it will do, the speed of that erosion will reduce a little bit and then overflow. All right, depend on the how blockage is that erosion, we determine the one that will be flowing to that side. But if we put a bigger block before it means that it's until the current overflow and little one will be dropping here. The little erosion, also represent as flow of current, will be dropping here. Little one will be dropping here. So the block between them is what we call resistance. Okay, so in between the ground and the line, the circuit line, so there is a low permission, just like this small current. It means that the current going to the ground is very much. So the permission we give to the current here is very small. The blockage we give to the current in 5 volt line is very big. Hope you understand. So that's what we are measuring. Mind you, it's not that circuit is designed like that, but it is the multimeter that will give a little current in order to test the line, to know the distance between the line and the ground, their obstacle, how they are so close to the resistance between them. Okay, hope you understand. All right, so that's what we are measuring. That's why the GR reading is very one of the best method. Okay, we understand better when because we are still going on schematics, so we understand better. All right, so let's move further.